So thank you for joining this time, super early. We'll talk a little bit about data contracts today. My name is Jochen. I'm German, so this will be a very serious talk now, no jokes allowed. My background, I'm working as a consultant at InnoQ, and my background actually is software engineering. So I do write Java code, or I did write Java code, talking a lot about software architecture patterns. And like 2 or 3 years ago, I started to do data-driven development. So we use data a lot in looking at what do we do next, how do we prioritize our features, and what is worth implementing and what actually not. And that was also the reason why we looked at how can we do data decisions better, and we were looking at the data mesh principles that were written by Shamaktigani, and well, we kind of had the impression that the perspective from software engineering was lacking a little bit. So we started to write it down on a website called datamesharchitecture.com, which I co-authored. And more recently, we found out that something was missing in data mesh, and that are data contracts. So we created a datacontract.com where we presented our view on how data contracts should look like and how they interact with data mesh. Currently, I'm also working on a commercial product to manage a data mesh called the Data Mesh Manager. That's what I'm currently working at a lot. That also includes a meta view on data products and data contracts, how to manage them. So let's start with a short recap. What is data mesh? And you probably have heard of the 4 core principles of data mesh when you're here in a data talk. So there is domain ownership, where we give the ownership of data to the teams that know most about the data. And these are usually the operational teams or the business teams, and we give them ownership over analytical data as well. And the first principle. And the second principle is that we want to apply product thinking on data. We want to treat data as something really valuable, and we want to present data to our consumers as they would be our customers. So this is data as a product, and not to confuse with data product, which is kind of similar in terms, and it's also in this principle here, now data product by a domain team. A data product is more a technical solution on how to implement things around data, but the principle here is data as a product, which really focuses on the consumer optimizing to make it really, really easy and understandable for our consumers to look at data. The third principle, self-serve data platform. There is a team that creates a domain-agnostic platform or infrastructure, so to make it our domain teams super easy to build data products. And the fourth principle is federated governance. When data is distributed, as data mesh is a socio-technical system that distributes the ownership of data. First principle, domain ownership. We still need a way to have a common sense of how we want to look at data, how we want to govern data, how we want to manage data, what are the rules of play in our data platform. So the transition goes from that we used to see in many enterprises to have a central data team handling all requests and managing the central data platform, a data warehouse or a data lake. And with data mesh, this goes to a decentralized, distributed way where the ownership of data is distributed to the domains that are really close to the business units. Okay, so we have this transition from central to distributed ways of working. And what we see here is the white rectangles in here. These are the data products. So, for example, we have in the checkout business domain 2 data products, one that focuses on orders and one that presents data around the customer to others, so others can access it. Maybe a little bit more details on how a data product looks like. And data products are modules that contain everything that is necessary to store and transform data, and also everything that's required from an engineering perspective, like tests around data, like observability. It includes the CI/CD pipeline to deploy our transformation code to the infrastructure. But also we have documentation, ownership, and lifecycle all around it. What you usually see a data product is managed in a Git repository, and there everything is included, and we have some Terraform code that defines the resources on the data platform. For example, I need a database or I need a bucket in S3, and since the transformation code is deployed and triggered on a regular basis. And at the edges, we have ports. We have the output ports on the right. The output ports are the endpoints, the API that makes data accessible for others. And we have input ports on the left, which refer how data comes into our data product, how to store data, for example, the connection to a Kafka topic or a Fivetran import or something. Or we have input ports that are references to other data products output ports. So we can combine data products, like in this diagram here, to build aggregating or consumer-line data products. And also we have a discovery port on top where we can describe ourselves to share the metadata with others. So this is data product when I say something about data products in output ports, okay? Now let's look at the data consumer experience. So I'm a consumer and I'm from a foreign team, and I want to look at, let's say, customer data. So I want to build a report that includes customer data or order data or something. And what we usually do is we start in our data warehouse, like here in Google BigQuery, and we look at the actual tables that are there. So there are projects, there are data sets, there are also tables and views, and we try to understand what's there, what can I use. And as you all know, there are thousands and thousands of tables in your data warehouse, and it's hard to find anything. And data is not too often too self-describing. So it's really hard to understand what are semantics behind it. So what most companies have introduced are data catalogs. Data catalogs try to manage or extract the metadata of the data sets or assets, or tables, whatever you have, and to make them discoverable and to add meta information around it, like descriptions, like referring to business terms in a glossary, and also to give tags so that you can do automations around it. But unfortunately, most data catalogs look like this. So what a data catalog does is it scrolls all the available tables and adds them to the data catalog, and nobody really maintains the entries there. And well, that's the same with with Google, with AWS and the Glue data catalog, and also in more advanced data catalogs, Data Hub or Collibra or Athlon or something, we really have the problem that data is not described too much. And why is it? Well, I would say it's because of the broken window theory. So if there is a mess, if nobody manages the metadata, like the taxonomy, the tags, the documentation, and the catalogs, and I see that 99% of the tables are not managed very well or not documented, so then nobody is really willing to contribute or to use it because it gains no value when you look at data catalogs by myself. And yeah, data catalogs are really only used by data governance people, like data stewards or something. So say yeah, you need to document your data sets there, but I mean, reality is nobody really likes to work with data catalogs. So we need a better way to specify the data APIs. So the real data that we can access and that are good managed, yes, the output ports. Yeah, so that's my theory around it. We need a better way to specify data APIs. And another thing is, what do data consumers trust? And the answer is nothing. Because why is it? Because they are disappointed too often by bad data quality, I would say. And yeah, what do? We look at lineage graphs. So we're used to look at, and that's a short one, we look at every column and look back, where does this data come from? So from every intermediary table out there, look back, where's the original data come from? And this, of course, does not scale very well, especially if you have a distributed data architecture. And the next theory I would say is we need a new boundary of trust. Basically, we need a trust boundary where we can say, okay, I do have something in between that I can trust. And this is when it comes to data contracts. We want to have data contracts as a new boundary of trust. If I look at a data contract, I believe that what's defined in there is true and trustworthy. Data contracts are quite new, not super new. So the term data contract is used quite a while now. It's already used by many companies like Go Cardless or Andrew Jones wrote a pack book how they use data contracts, and he also gives like definitions that I like. So he says, a data contract is an agreed interface between the generators of data and its consumers. It sets the expectations around the data, defines how it should be governed, and facilitates the explicit generation of quality data that meets business requirements. Okay, so I think it's worth reading the book. However, it's kind of optimized for Go Cardless. And also there's PayPal. PayPal also uses data contracts, and they released their data contract template recently. And yes, it's a YAML structure that they have. So they have a YAML where all information, logical, physical information, but more importantly, ownership information is defined in a YAML specification or YAML file that contains the schemas, data quality, service level agreement, and also security and stakeholder information. However, as the leading person at PayPal left PayPal, it's not updated anymore, unfortunately. Then also dbt. Who uses dbt here? Okay, not too many. You know dbt? Also not too many. Okay, dbt is a tool for data transformations. And they have a nice concept of models and describing the metadata around it. And in the last version, 1.5, I think, they also introduced the concept of data contracts, where dbt runs a pre-flight check to ensure that the schema is in line with the specification in here. So before they do any transformation, they check if the output of the transformation would actually meet the defined schema, which is pretty cool. However, it's dbt specific. So if you work with something else as SQL transformations, or if you use Spark, for example, you probably do not want to use dbt. And so we looked at these different flavors of data contracts, and we were not super happy because, as I mentioned, I'm coming from software engineering. I used to work a lot with OpenAPI or Swagger API definitions, and also with AsyncAPI definitions that describe messages, like in Kafka or in IoT messages. And they follow some conventions. So OpenAPI and AsyncAPI merged quite a bit in how they present also data, what the structure of the API documentations is like. And that was, in our point of view, this was missing for the existing data contract templates out there. So that's the reason why we propose a data contract specification that is in line with OpenAPI and AsyncAPI specifications. Easy to read, easy to write, actually. And also we currently refer to the existing schema definitions. Like there is this model specification in dbt, and we adopted it to be used. But if you do not have tables, but like JSON files or Parquet files as a file structure, you work with your data, then you can also use things like JSON schema or anything. Okay. How do data contracts now relate with data products? Well, this is a picture we have seen earlier. And yeah, basically a data contract specifies the interface that an output port implements. Okay, so this is a relationship. We have data contracts as a specification for the output port, or data API, if you prefer the term. And if you have another output port, you can have another data contract that specifies the second output port, or it could be the same, by the way. So you could have one data contract specifying two different output ports if they present different views with different filters, for example. So this is a bit like in Java, where you can have an interface and a class implementing the interface. Think of it like that. But you can also have a data contract for the input ports, especially if you have unreliable sources you do not control. You can say, on my input port, I do have some expectations for the schema and for the data quality that you can probably check before you do anything with the data. Okay, now look a little bit more in detail. What is the content of a data contract? And yeah, we do have ownership information. We have terms and conditions. We have a schema. And more importantly, we have semantics around data. We have examples. We have quality and SLOs. And we have servers and physical information. Let's look in detail into it. So we here have a data contract with the ownership and naming and IDs and everything. So that is basic information you probably have. And yeah, data contract has an ID. We use a URN here, but could be a UID as well, or anything, basically. And it's the title of the data contract and a description what is this data contract specifying, and we have a version, so version 4. Versioning, of course. But more importantly, are the ownership information. So which domain team is responsible for this data contract and contact information. And here's a things that we have seen at Lidl, so the supermarket chain. They use data contracts as well, and they have a Microsoft Teams channel for every data contract. And they use this channel for notifying updates on a data contract, but also for communicating with the providing team and the consuming team. And that's something that could be easily referred here. And also the creation of the Teams channel can be created automatically once a data contract is created. And that's really working well for them. It's a simple way of communicating. It's the API for the team and the consumers based on their existing communication infrastructure. Okay, next, terms and conditions of a data contract. Here, the owner can describe how potential consumers can use the data and what they are allowed to do and what they are not allowed to do in a business or legal or also a technical point of view. Okay, and especially the limitations are really relevant for when it comes to data governance, which we cover later. And also, we like to see this billing information here to give access to data a price. And that means it gives it a value. And this is really in line with the second data mesh principle, data as a product, where when you develop a product, you expect your customers to pay for it. And I mean, we usually talk about data products that are shared within one company, but you can also have things like internal cost accounting or something around it and implement it. And this is also a really relevant thing for your product owners to say, okay, this data product to implement is really valuable for our consumers. I rank it high in the backlog because it gets me more money, more budget for it. And if you bill your consumers, you probably also need a way to end this agreement again. And we introduce this notice period idea. So providers or consumers can cancel the usage on the data contract again to have a life cycle in here. Maybe because it gets too expensive, or as a provider, you probably want to evolve your data product further. You need to introduce a breaking change. Then you can say, okay, dear consumers, you need to go to another version of the output port, which contains a breaking change, and we give you 3 months time to do this. And afterwards, we are shutting down the version 1 of it. Okay, now let's look at the schema. The schema is kind of similar of what we have seen in data catalogs, but here it really goes more in the definition of the semantics around the data. So we do have here, again, nobody really likes to do it, but here's a place where you can do it, and as there are way fewer tables you share with others than you have for your internal processes, for your internal transformations, there might be some more willingness to think about it and to describe the data and the semantics in here. Again, this can be done in YAML structures like your DBT model. And if you already use dbt for transformations, you can refer or include the model you already have for dbt or for JSON schema or anything. And what we also find very, very helpful in a data contract are examples. So especially when you have new customers or consumers or potential consumers, and you have business users, and they look at a timestamp like this, the first question you usually get is, what does this set at the end mean? And we engineers all know that it's UTC timestamp, of course. But that's something you probably need to discuss with your consumers that, yeah, if you want to have it in your local time zone, you need to convert it, or you need to configure your BI tool to convert it. But yes, that's really worth talking about. Also, order total here, we see it here that this is modeled in euro cent and not in euros. So it's really important to tell your consumers that if they want to have the euro value, they need to divide it by 100. Yeah, and these are questions that get asked if you look at these examples. Then we have quality. Quality refers to things that we can check on the actual data sets. So that are basically tests or queries. We can query our tables and check if our assumptions are met. And same as with schema, we refer here to a language that is already used. Like here it's Soda's checks language, and there is an engine behind, like Soda core, that can read this definition and execute the tests or the checks really on the output port or on the input port. And we think it's really important to have this executable, and not only specifying it, but make it executable. And that's also the difference to service level objectives. SLOs are not executable on a data set, like availability or support times or something that are more descriptive in contrast to quality attributes. And then we have servers. So these are the actual endpoints where the data is provided. That's a reference to the output port. And it's optional. So we come to it later. When we say about starting contract first, this is something to add later to the data contract probably. And as already mentioned, the language of a data contract is usually YAML, and you can use tools that make a nice rendering around it, of course. But the data contract itself is written in YAML. As today, everything is written in YAML. Okay, maybe a word on terminology. Something I'd like to point out is, and we pivoted here really a lot, had so many discussions, and everybody, or no, not everybody, but the data contracts we've seen earlier, like at PayPal, at Go Cardless, in dbt, these are not contracts in a legal sense as a real agreement between two parties. They are not. They are more an offer to potential consumers. So data contracts describe the interface, but do not know their consumers. So it's not a one-to-one relationship between one data product provider and a consumer, but it's owned by a data product owner. And yeah, they're describing the interface of the output port, of the input port. I really want to stress this because That's really helpful if you go into discussions about data contract, make clear what you mean. And there are some others that refer to data contracts as this one-to-one relationship. And we also use this one-to-one relationship, but we call it data usage agreement. Also call it subscription on data, which we do not like because we work too much with messaging services like Kafka, where you also have a technical subscription, which is kind of different. We're not super happy with data usage agreement as a term. Might be changed in the future. But this is the relationship between a providing data product and the consuming data product. So you need to model this entity as well, this one-to-one relationship. And why is it? It is because data cannot protect itself. Meaning, when data is out, when data is copied by your consumers, you do not have any control what they're doing with it. So you need a way of to define, first to know your customers, but also to know what are your customers or consumers are supposed to do with the data. And this is why we usually work with kind of request access workflows, where a potential consumer who wants to access your data for not purport under a data contract needs to say what they're planning to do with the data. And then you can approve or reject the access. And you can also implement automations to set or to grant the permissions or to revoke also the permissions later on when this data usage agreement is terminated later. And that's important as well. First, to know who your consumers are. And as there's a life cycle, and this data usage agreement can actually be terminated with a notice period, you have a way to evolve your data products and ask your consumers to go to another data contract or to another output port. Okay, next topic, how are data contracts created? And I want to stress here this collaboration thing because it's something that's was really missing in data engineering a lot. And what we can get with data contracts is a contract-first approach when we discuss with our potential consumers what they really need. In data engineering, we are mostly used to work with existing data and look what can we do. But with data contracts, we now can do requirements engineering and look at what do our data consumers really, or our business users really use. And we can specify these requirements in a data contract as a common language between our data providers and our data consumers. We can start with a YAML specification before we implement the data product that provides all this data. And when we write it down, it makes expectations of our data consumers very explicit. When we start defining the schema or looking at the examples and specifying the description first before we have the data, it makes many, many expectations explicit and it starts so many discussions. And the same with domain knowledge. Domain knowledge is usually at the data provider side. And they have a way to make their knowledge explicit when data consumers and data providers discuss with each other. So what we do in workshops when we work with customers on data contracts, we usually have a meeting and we invite the data product owners and the data consumers and we bring them together. We start with the examples. We start with how should data look like and write it really down, for example, in an Excel file, super simple. And then we have also discussions that are around it and we compose the results of the discussion in the YAML structure of the data contract. And we do it on a shared screen. So if we do it in person, we have some presenter with the data contract with the YAML. If we do it, we can also do it with Zoom or Teams, of course, virtually. And yeah, we share the screen with the YAML. So we can negotiate the terms and quality attributes, but this is an ongoing process usually, especially for the data attributes. So they are often added when you discover some things that you didn't expect before in production. So now we have a YAML. Now we can implement our data product to fulfill the contract. And as it's YAML and as it's machine readable, we can also have contract testing. So we can have data contract enforcement. And we can add checks in our CI/CD pipeline that looks at the schema and compares the actual version of the schema that is provided by the transformations and compare it with the data contract schema that our consumers agreed in the data usage agreements. And if there is a breaking change, we can break the CI/CD pipeline and notify our providers that, hey, you should look at this. And also we can use software quality tools like Soda to check the data quality attributes when they access to the real databases. So we can use contract testing in our CD pipeline, and we can detect changes before they are deployed. And this requires, of course, tooling in our data platform. Our data platform team needs to provide a way to automate it. So it shouldn't be done by each domain team on their own, but it's a capability you want to have in your data platform, of course. So let's talk a little bit about federated governance. And data contracts are a way of data governance. So when we talk about governance, it's often about, well, ownership. So who is responsible for providing the data? I mean, that's kind of obvious. We have the ownership information in the contract, but also on quality. What quality do we provide? And here we have the quality and SLOs section in the data contract. But looking more at things like compliance or legal stuff. So, for example, in which region are we actually allowed to store data? If we have European data, it maybe only be located in European data centers, and that's something we can add to the terms and conditions of the data contract. So our consumers know what they're allowed to do. And looking at privacy or classification, like sensitivity levels, so something that we can also define as a term, so we can define it as tags or special attributes in our schema as well. And a security, also important thing in data governance, is who has access to which data and why. And this is what we have seen with data usage agreements. And the nice thing is here, a lot of these things can be done federated by the domain product owner. So you do not really need a central governance team looking at the things, but you have data contracts and they are implemented decentrally. Maybe one more thing, with data contracts, we can have nice discovery, maybe cleaner than what we have with data catalogs. So we can register data contracts in tools like Data Mesh Manager or in other tools. And as the contracts are pretty good documented, especially when you start contract first, that's a good way to discover what data you have available for other teams. Maybe more on tooling a little bit. Well, we have the data contract specification as YAML. And what we also implemented is a studio, data contract studio, that you can use, which renders the data contract YAML and makes it available also for sharing. So we have a shared link that you can send to others so that they can look at a data contract, and you can also edit a data contract with a Visual Studio Code style web editor with code completion and everything. And more importantly, we implemented a data contract CLI tooling that's open source. So we really believe for data contracts to be successful, we need open source tooling around it so that we have developer acceptance and experience. And that's what we have with a data contract CLI that does linting, running tests, printing the schema so you can easily reuse it in your dbt pipelines, for example, or in your SODAs, the quality attributes. But also we're currently working on diff detection and breaking change detection. So let's look at a short example here, and then now we're kind of running out of time. But let's look at this here. We have a little bit too fast. So we do have, I cannot really control it. So we do have two data contract versions. And if you change something, like we change the data type from timestamp to a string, which would be a breaking change, the data contract CLI could detect it and exit with a exit code that is not 0. So that would actually break the CI pipeline and gives also information around it, so that you can see it in your pull request, for example. Okay, now as a summary, we propose data contracts for collaboration to start contract first, if you can, to define the requirements and collaborate what your consumers and business users really need. We can have contract testing. We have federated governance and a nice way of discovery, finding available data contracts. Have a look at datacontract.com. Tell me what you think on the standard, on this proposal. And I'm not quite sure if you have many time for questions. So 2 questions, probably. Okay. Hugo? Mm-hmm. Yeah. I think really important is the terms and conditions you provide, so you really say, okay, here, when you want to access this output port, you are expected to do this, and you can do this, but you're also limited to do things. And the second thing is, as you have way less information you need to manage, I think it's easier to manage data contracts and all the tables you have out there in your data catalog. But I think the manual process is really a thing. Okay, so thank you so much for having me.